Imagine stepping onto a train that travels faster than most airplanes during takeoff. A train capable of reaching speeds of over 320 kilometers per hour, carrying millions of passengers every year with incredible precision. Now imagine this. Despite operating for more than 60 years, Japan's famous bullet train has never experienced a fatal passenger crash caused by a train collision or derailment during normal Shinkansen operations. How is that even possible? Is it because Japan has the world's smartest engineers? Is it advanced artificial intelligence? Or is there a hidden safety system that most countries still don't have? In today's documentary, we'll uncover the incredible engineering behind Japan's Shinkansen, the world's safest high-speed railway. From earthquake detection systems to perfectly designed tracks and one of the most disciplined transportation networks on Earth, you'll discover why millions of people trust this train every single day. Let's begin. After World War II, Japan faced a massive challenge. Its economy was growing rapidly. Cities were becoming crowded, businesses were expanding, and millions of people needed to travel between Tokyo, Osaka, and other major cities every day. The old railway system simply couldn't keep up. Road traffic was getting worse, airplanes were expensive, and conventional trains were too slow. Japan needed something the world had never seen before. A train that was incredibly fast, unbelievably safe, and reliable enough to operate every single day without delays. Many experts believed it was impossible. Some even said trains should never travel above 200 kilometers per hour because they would become unstable and dangerous. But Japanese engineers believed otherwise. Instead of improving old railways, they made a bold decision. They started from scratch. Every bridge, every tunnel, every rail, every station, and every safety system would be designed specifically for high-speed travel. This project became known as the Shinkansen, or as the rest of the world now calls it, the bullet train. When the first Shinkansen opened in 1964, just before the Tokyo Olympics, the entire world was shocked. It wasn't just fast, it completely changed the future of railway transportation forever. So, what makes Japan's bullet trains so incredibly safe? The answer isn't just one technology. It's a combination of hundreds of engineering decisions working together perfectly. Unlike normal railways, the Shinkansen does not share its tracks with freight trains or slower passenger trains. That means no unexpected crossings, no traffic interference, and no vehicles blocking the railway. Every kilometer of track is built exclusively for high-speed trains. This dramatically reduces the risk of accidents. The rails are built with extremely tight tolerances. Even tiny imperfections that most people would never notice are repaired immediately. Engineers inspect the tracks every single day using specialized inspection trains packed with advanced sensors and cameras. These inspection trains can detect problems long before they become dangerous. One of the biggest reasons the Shinkansen has such an outstanding safety record is that drivers don't control the train alone. An advanced automatic train control system constantly monitors the train's speed and location. If a driver accidentally exceeds the safe speed limit, the computer immediately slows the train down automatically. In many situations, the computer reacts much faster than any human ever could. Japan experiences thousands of earthquakes every year. Running a train at over 300 kilometers per hour during an earthquake sounds terrifying. So how do they prevent disasters? Japan created one of the world's fastest earthquake warning systems. Hundreds of seismic sensors are placed across the country. The moment these sensors detect the first seismic waves, a warning is sent to the railway network in just seconds. Before passengers even realize an earthquake has started, electricity to the tracks is automatically cut off, and every bullet train immediately begins emergency braking. This gives the trains precious seconds to slow down before the strongest shaking arrives. It's an incredible example of engineering designed to protect human lives. Safety doesn't stop after the trains are built. Every night, when passenger services end, maintenance teams inspect tracks, tunnels, bridges, overhead power lines, and signaling systems. Any issue, no matter how small, is repaired before the first train departs the next morning. In Japan, safety always comes before speed, and that's exactly why millions of passengers trust the Shinkansen every single day. But safety isn't the only thing that makes Japan's bullet trains extraordinary. They're also among the most punctual transportation systems on Earth. The average delay is measured in seconds, not minutes. Imagine millions of passengers traveling every day, yet trains still arriving almost exactly on time. How is that possible? The answer is simple: discipline, technology, and planning. Every departure is carefully scheduled. Every train is continuously monitored from advanced control centers. Weather conditions, track temperatures, train positions, and maintenance data are analyzed in real time. If anything unusual is detected, operators can respond immediately before it becomes a serious problem. Another impressive feature is the train's aerodynamic design. The long, pointed nose of many Shinkansen models isn't just for appearance. It reduces air resistance, improves energy efficiency, lowers noise levels when passing through tunnels, and helps the train remain stable at extremely high speeds. Even passenger comfort is part of the engineering. Special suspension systems reduce vibration, making the ride feel incredibly smooth, even at speeds exceeding 300 kilometers per hour. The next generation. Maglev Japan isn't stopping with the Shinkansen. Engineers are already building the next generation of high-speed transportation, the maglev. Unlike traditional trains, a maglev doesn't ride on wheels. Instead, it uses powerful magnetic forces to lift the train above the track. With almost no physical contact, friction is dramatically reduced. This allows the train to travel at speeds of more than 600 kilometers per hour, making it one of the fastest ground transportation systems ever created. Imagine traveling between major cities in nearly half the current time. What once sounded like science fiction is quickly becoming reality. Japan's bullet train isn't famous simply because it's fast. It's famous because it proves what happens when engineering, discipline, and innovation come together with one goal: protecting human life. Every bridge, every tunnel, every rail, every sensor, and every line of software is designed with safety in mind. That's why the Shinkansen has become a global symbol of reliability and engineering excellence. As countries around the world continue investing in high-speed rail, many of them look to Japan as the gold standard. The next time you see a bullet train racing across the countryside, remember, you're not just looking at a train. You're looking at decades of innovation, precision, and one of the greatest engineering achievements in modern history. If you enjoyed this documentary and want to explore more incredible engineering marvels, mega construction projects, and futuristic transportation systems, make sure to subscribe to the channel and turn on notifications. Thanks for watching, and we'll see you in the next video.